Okay guys, we are going to show that the gamma of 1 over 2 is equal to the square root of pi. Okay, let's start with the gamma function's definition, which says the gamma of n is equal to the integral from 0 to infinity x to power n minus 1 e to power minus x dx. Now if n be 1 over 2, then the gamma function will take this shape. The gamma of 1 over 2 is equal to the integral from 0 to infinity x to power 1 over 2 minus 1 e to power minus x dx. Then it is equal to the integral from 0 to infinity x to power minus 1 over 2 e to power minus x dx. And we let, it's a very important part of the proof, we let x equal to u square, and by the way, dx is equal to 2u du. And if x approaches to infinity, this infinity, if x approaches to infinity, then the value of u square approaches to infinity. And if x approaches to 0, then the value of u square approaches to 0. Then the boundaries of the integral are the same. Now we rewrite this integral and we substitute these values from the letting part. Okay, we say the integral from 0, it will be equal to integral from 0 to infinity. Instead of x we have u square. We say u square to power minus 1 over 2 e to power minus u square 2u du. Instead of dx we have 2u du, dx equal to 2u du. Then we have to write it. We mustn't have any x in this step. The variable here is u. And if we simplify it, we see that it will be the integral from 0 to infinity u to power minus 1 e to power minus u square 2u, and you know it is to power 1 du. Then it's u to power minus 1, it's u to power 1. The result of multiplying these two variables are, it's equal to 1. Then what is the rest is the integral from 0 to infinity e to power minus u square 2 du. Since we can take the constant out of the integral, it will be 2 integral from 0 to infinity e to power minus u square du. And we can say this integral is to this integral, to integral from 0 to infinity e to power minus v square dv. It is just the name of the variable. This integral is in u and this integral is in v. They are the same. There's no difference between these two integrals, just it's u, it's v. So they are exactly the same in mathematically. And we square both sides of the equality here, since we have the gamma of 1 over 2 and it is equal to this integral. The gamma of 1 over 2 is equal to this integral or this one. If we square this, the left hand side of the equality, we have to square the right hand side of the equality. Now the gamma of 1 over 2 all square is equal to this one square, and we say that this integral is equal to this integral, and we can write instead of this integral square, we can multiply these two integrals. We say 2 integral from 0 to infinity e to power minus u square du multiplied by 2 integral from 0 to infinity e to power minus v square dv. And it's equal to what we have is for the double integral from 0 to infinity, 0 infinity e to power minus u square plus v square. This minus is the common factor between minus u square and minus v square. We can take it out, and we have the first one is du and the second one is dv. Now it has the double integral shape, and we don't have the derivative of the power down here. We have to change it to polar, because we can't solve this integral in Cartesian or in yes, we can't solve it in Cartesian product. We have to change it to polar, and to change this to polar we let u be equal to r cosine of theta and v equal to r sine of theta, and r square is equal to u square plus v square. And likewise the du dv is equal to r dr d theta. It's rule and it's proved. We substitute these values of the letting in this double integral, but firstly, if we look at this one, this integral is in the first octane, because the values of v, let's say it's u and it's v, the values of v, they are from 0 to infinity, and the values of u, they are from 0 to infinity. Then this integral is in the first octane, and in the first octane of polar coordinate we can write the double integral like that. The first octane in the polar coordinate system is we write it as for integral. The first one is for theta. The theta is the angle. Here in the polar we have the angle from 0 to pi over 2. And the second integral is about r. We have the r is the radius. We have the radius anywhere from 0 to infinity. And we write this, it's e to power minus u square plus v square, u square plus v square. We can write, instead of u square plus v square, we can write r square. It's minus r square, and r dr d theta. Now we solve the first integral. We get 4 minus 1 over 2 integral from 0 to pi over 2 e to power minus r square from 0 to infinity. These boundaries are these two. And so this minus 1 over 2 is what? This, it is minus r square, and the derivative of minus r square is minus 2r square, minus 2r, and we have only r here. We have to multiply it by minus 2, and we have to multiply it by minus 2, and here we have to add minus 1 over 2. This minus 1 over 2 is this one. Okay, and we have the theta here. This integral, we have to solve it with respect to theta, but after substituting the boundaries, we get the minus 2 integral from 0 to pi over 2, 0 minus 1 d theta, and this minus with this minus, they cancel each other out, so it will be 2 integral from 0 to to pi over 2 d theta, 1 d theta, and it will be 2 theta from 0 to pi over 2, and it's equal to pi. 2 times pi over 2 minus 0, it will be pi. And if you remember, we squared the gamma of 1 over 2. Now step by step, we now have the gamma of 1 over 2 square is equal to pi. Then the gamma of 1 over 2 is equal to the square root of pi. Okay, thank you for watching.